What's going on, guys? Let's try this problem right here. Here we have a Bernoulli differential equation, and let's see how we can solve this. And Bernoulli's differential equation is basically same as similar to linear first order differential equation. The only difference is we have this y power this value. So if it's 0 or 1, it's going to be linear, but if it's greater than 0 or 1, it's going to be a different thing, right? So what we had to do is, in this kind of problem, we try to bring this one into linear first order differential equation pattern, and then we try to solve it. So to do that one, what we had to do is we had to pick a v value. So v value is basically whatever the value we have right here. So this is going to be our n number. If you notice this equation, v is equal to y power 1 minus n. So this is the equation we are going to use. N is basically the power number of power. So here we have square, so n is going to be equal to 2. Then we have to find the v value. V is going to be equal to y power 1 minus 2. So we are going to have y power 1 minus 1, right? So this is going to be v is equal to 1 over y. Therefore y is equal to 1 over v. Now what are we going to do is we are going to replace all the y values with v value in order to solve this one using linear first order differential equation pattern. Now to replace this one, first we have to find the derivative of this one. So when we find the derivative, since we are going to find the derivative respect to x, because we are going to use dy dx, so respect to x, this is going to be a chain rule. So when we take the derivative of this one, what's going to happen is, so let's write this one like y is equal to v power minus 1. So when we take the y prime, this is going to be v power, so minus come from right, so this is going to be minus v power minus 2 and times dv by dx. So we are we are finding the derivative of this one respect to x. So we are going to have this one. Now all we have to do is replace this y values with this v values. So first we know y is equal to 1 over v and y prime is equal to this value. Now let's go ahead and write our new equation. That's going to be minus v power minus 2 dv over dx and plus x, instead of y we place this v power minus 1, right? So v power minus 1, and then x, instead of this y square we replace this one with v power minus 2, because v power minus 1 square, that's going to be v power minus 2. Now we have this one, and this is not still in linear first order differential equation pattern, because in order to have linear first order differential equation, we have to have dv by dx alone in the first part. So to get that one, what we do is we divide everything by this value. This is going to be divide everything by v minus v power minus 2, and this also minus v power minus 2 minus v power minus 2, and finally we will end up with dv by dx, and this is going to become minus, and we are going to have square minus 1, that's going to be xv, and in the other side of the equation we are going to have minus x. So we have this one right now, and this is linear first order differential equation pattern, right? Now we can go ahead and use linear differential equation method to solve this problem. So to do that one, first of all we have to find the integrating factor, that is e power integral p of x dx. So p of x is basically this value, right? So if you look at the equation, p of x is whatever the value comes after dy dx and in front of this y value. So here this is going to be our p of x. P of x is equal to negative x right here, and if you find the integrating factor is mu of x is equal to e power integral of p of x dx, and this is going to be e power negative integral of x dx, and if you find the derivative of this one, that's going to give us e power negative x square divided by 2, and this is going to be our integrating factor. Now what we have to do is we have to multiply this equation, both sides of this equation, by this integrating factor. So we are going to multiply this side e power minus x square divided by 2, and this side is also e power minus x square divided by 2. Now after we multiply, we will get this one. The first term is going to be, so we take the d and dx this side, and we are going to have v and this combined, that's going to be e power minus x square over 2, right? And the other side we are going to have x e power minus x square divided by 2 v, and in the other side of the equation, that is going to be equivalent to minus x e power minus x square divided by 2. And if you remember the method of solving the first order linear differential equation, if you find the derivative of this part alone, that's going to give you the whole part again, right? So what we can do is we can take this one alone and equate to this one. So let's write this one. I get rid of this part, I need more space. Okay, let's continue this one right here. So here we are going to have d over dx v e power minus x square by 2 is going to be equal to minus x e power minus x square over 2. Now we have to integrate both sides. So in this side, we are going to integrate this one respect to x, and other side also we are going to integrate this one respect to x. And here if we integrate this one, this derivative and integral cancel each other, so we are going to have left with this one alone. And in the other side, we are going to have negative, we have this one right here, so we have to do something about this. Now let's see how we can integrate the other side. So we have this one, we have minus x and e power minus x square over 2, and let's write this one integrate. If you integrate this one, that's going to be just v e power minus x square divided by 2, and in the other side we are going to have minus x square e power minus x square divided by 2. So here we had to do the u substitution. So let's take u as negative x square, maybe negative x square divided by 2, maybe, yeah, x square divided by 2, and du is going to be minus 2x dx, so minus 2x dx divided by 2, so this is going to be minus x dx. And if we write this one in terms of u, everything in terms of u, we are going to have e power u du. So when you integrate, that's going to be just e power u, right? E power u plus constant, and we know that u is minus x square divided by 2, minus x square divided by 2 plus constant, and that's it. After that we replace that one right here. So we are going to have e power minus x square divided by 2, that's going to be our integration of this one, plus constant. Now to write our final answer, we had to divide everything by, we had to bring this to this side. So this is going to v is going to be equal to, if you divide everything by e power minus x square divided by 2, this is going to be 1, and this is going to become c e power x square divided by 2, and that's it. And finally we had to write this one in terms of y, and we know that previously we solved it that v is equal to 1 over y, right? So instead of v, we are going to write 1 over y. So 1 over y is equal to 1 plus c e x square divided by 2. Therefore y is going to be equal to 1 over 1 plus c e x square divided by 2. So this is the final answer. And That's it, right? So that's gonna be our final answer. I hope you guys find this video helpful. See you next time.